Good evening. Welcome to our very first revision class on formal logic. But I'd like to invite you on this journey so that we can go forward together and best prepare for the exams. Right now, for those of you who have been with us during the semester, you realize that we are going to have a change of uh, the way that we've been doing things. So during the semester, we concentrated or oriented towards the assignment. Right? But now our focus will shift um, to exam questions in past exam papers. So even our method or structure of operation will be different or will be with regards to that. Now, I want us to acknowledge the fact that before the complications associated with the introduction of take-home exams, there was already a section of multiple choice included in our question papers, right? So that is, I think, might remain there, right? But then there will also be a written section, right? So most likely, from the feedback that I've been getting from other modules, um, it is going to be a take-home 2-hour exam, then with time to download and upload, most likely open book, and then you're able to upload the answers. Right. Now, before we start, if they confirm that it is an open book, read for it and prepare for it as if it were a closed book test. Right. Prepare for it as if it were a closed book test. The moment you go and you start reading, you are losing marks. Why do I mean when you say you're losing marks? Because in an exam situation, you've got 100 marks and you're supposed to deliver those 100 marks within 2 hours. So you're looking at around about 80 seconds per mark or 1 minute and 20 seconds per mark. In that case, right, if it is 1 minute 20 seconds per mark, if you spend a minute scrolling through and trying to find the solution, it is 1 mark that is gone. Right. So I want you to prepare for this as if it were a closed book test. And then when you write, you start by writing what you know. If then there is something that you do not know, then welcome to consult the book. Again, the book is mostly gonna be able to give you definitions, right? And some scenarios, but not the exam scenario. So you should be able to anticipate that and make sure that all those scenarios are. Now, I think that is all that I can say for now. Is there anything that you would like to add? Have you received any more information regarding our how the exam is going to be like? Any information gained so far? So, like I said, we are going to take a slightly different approach. You see that in the during the semester, we were taking it and saying we started with propositional logic. We introduced some bit of predicates. We went all about it, catered for assignment one. Then we started with predicate logic. Then we dealt with that. But for these revision classes, or for the purpose of these revision classes, we are simply going to start off with defining predicates um, predicates um, and propositional statements, right? And then and the operators included in propositional logic and predicate logic. Right? So if you want to follow with me as to how we're going to be doing it, I'm starting off with the structured questions or from question 2 going forward, right? Then we're gonna do question 2, question 3, question 4, question 5, and then by the time we are done with that, we should be able to answer all the multiple choice questions. All right. So let's begin. So let's start with what we call propositional statements or propositional statements or atomic sentences. Right. So these are statements that are always going to hold a true or false value. It does not really matter whether they're true or false, but the fact that they hold a true or false value. Right. Now, examples of propositional statements, we can see the sum of the number 3 and number 5 is equals to 8. Right. I can even so say the sum of 3 and 5 is equals to 10. It will still be a propositional statement because that statement can either be true or it can be false. Right. Jane reacted violently to Jake's accusation. Either that happened or that didn't happen. Right? Every even natural number greater than 2 is the sum of two prime numbers. Right. So that is true. Every even number greater than 2 is the sum of two prime numbers. Right. So if you look at 4, it is the sum of 3 and 1. If you look at 6, it is the sum of 5 and 1. Right. So you can see how we can proceed with that. Right. Now, some sentences that are not atomic sentences or declarative sentences are those ones which, well, we can neither be sure or we can. There is another question that you need to ask for you to have enough information to answer. For you to have the confidence to say true or false, you need to ask another question or gain more information related to it. For example, if someone says, "May fortune come your way," right? When someone says, "May fortune come your way," the only thing you can really say is thanks, right? Where there's true false, it does not have, or the question does not demand a true or false answer. So we cannot have that as a declarative sentence. Right. So what we see is the structure of declarative sentences needs to have an object of affection, or we can say a subject. It needs a subject, and then we need to have a description of subject. We need a subject and a description of the subject. Right. So if we have a subject and the description of subject, we should be good to go. So if I come here, right, what is the subject? So we've got two subjects here, 3 and 5, and then the description, the sum of these two subjects is equals to 8. What is the subject? Jane is the subject. And then her reaction to Jake's accusation is the description. Right. All Martians like pepperoni on their pizza. Subjects are Martians, and then the description like pepperoni on their pizza. So those are what we have as declarative sentences. In these ones, could you pass me the salt? We are not specified, or the subject has not been specified. Right. Ready, steady, go. Right. Too generic. There's no subject involved. May fortune come your way. No subject involved. All right. Now, let us see what operators we can apply to our predicate, our propositional statements. Conjunction. When we have got two propositional statements or declarative sentences, it is common in English that we can join sentences using English connectors. Right? So if you can follow what I'm saying, I've used, I think, about 5 connectors in this sentence. So if, whenever, whoever, a lot of these are called connectors in English. So we have things like that as well in logic. And the first one is conjunction. So the conjunction says, look, if I'm given two statements, one is P, the other is Q, right? If I know P is true and Q is true, then the conjunction of the two, P and Q, should be true. And the conjunction, I identify it by the words and but these two words speak of conjunction. Right. However, if one of them is false or both of them are false, then the conjunction of the two is false. If I say I am a boy and I am a girl, I am a boy and I am a girl. Right. So this statement is going to be false because I have to either be one of them is false, the other is true. Therefore, the statement is false. This will not hold. All right. Now, taking this off, we can then further go and look at disjunction. Disjunction is the common or that we talk about. Some can say either dash or dash. What does it say? If you have got two statements, right, and you have a disjunction between them, right? So now let's say I am a boy or I am a girl. A boy or I am a girl. So it says if one of these is true, at least one needs to be true. So since this is true, the whole statement is true. So if at least one of them is true, I've got true here, true there, therefore true there. At least one, so I've got a true value here, therefore true. I've got a true value, therefore true. Here I do not have any of them being true, therefore it is going to be false. That is conjunction. Then implication says if P then Q. If you see something like this, then it means that is an implication. Right, now, let's say, because this is much more demanding than the rest, we need to use a complex example. Right, we say if Kuda finishes his supper, then he will be given dessert. He will be given dessert. Hopefully I have this spelling correct. I'm usually confuse it with desert. Right. Now, given this statement, we want to identify, so P implies Q is the same as saying if P then Q, which is identical to or similar to what we have here. Right. So here we'll then say P simply means Kuda finishes his supper, and then Q simply means Kuda is given dessert. Now, given those two, we can come and say Kuda actually finishes his supper and Kuda is given dessert. Right? Therefore, this statement holds. Right? Because if Kuda finished his supper, he will be given dessert. Holds because he finished his supper and he was actually given dessert. Therefore, it's true. If Kuda finished his supper, but then is not given dessert, right, then a promise has been broken. Therefore, this statement is no longer true because the expectation was if he was to finish his supper, he gets dessert. He did indeed finish his supper, but he did not get dessert. Then here we see that if Kuda does not finish his supper, but still gets dessert, we see this is highlighted as true. How come? Right. Let's come back to it later on. Let's first start with he does not finish and he does not get. That makes sense, right? That makes sense. I did not meet the condition, therefore I did not get the result. So that makes sense, right? But this one over here, I still did not finish and I eventually ended up getting it. How can we possibly justify that? The question then becomes, what was said about Kuda not finishing supper? Is there a condition attached to Kuda not finishing supper? If there is no such condition, then anything can happen, whether he is given the dessert or not, is entirely at the mercy of the person who set the condition. Right? But if he had finished and then you did not give him dessert, Kuda could have taken you to court and said, look, I have fulfilled my part of the agreement, now you need to fulfill yours. Right? Think of this as an employment contract. And more so like in this COVID-19 era or space, where employers will say, your contract says if you do not work, you do not get paid. Right. So when you sign the contract, basically they will tell you that you will be working a 40-hour work week, right? So that's usually 8 hours a day, Monday to Friday, right? And you'll be remunerated, say 30,000, right? So that is generally, we can talk of the time that they are buying from you and what they are remunerating you for it. So if you work for a 40-hour work week, then you get remunerated 30,000. Now it comes to fruition that on the 24th or 26th of March, we enter into a lockdown. Right? Okay, fair and fine, March is done, but the whole of April, you have not been going to work. Right? For the 40 hours a week that you are supposed to work, you have not worked an hour for that. The situation is beyond the control of the employer. It is beyond the control of the employee. Right? Does the employee have the right to go and demand the salary from the employer? Whereas the contract said you get paid for working 40 hours a week. So if you want to file the claim, then the employer will come and say, please show me what you did on those 40 hours times 4, the 160 hours that I'm supposed to be paying you for. So that goes to the no work, no pay policy. Right? Now, in a contract, in that specific contract, you do not work. But well, everyone understands how it is at the current moment. Then the employer says, guys, this is going to be a difficult time for everyone. You are not going to be working. I'm still going to give you a full salary. Because in the contract, you find that usually there won't be a clause that will say if you get paid, how can I say, if you get paid, you're supposed to work, or there's no condition attached to you not working. Right? So there's no condition attached to you not working, as per se, to say if you do not work, we are going to do 1, 2, 3, and 4. But maybe some contracts you find that there, but usually it will not be there. So meaning it is now at the employer's rationale to say, do I pay? Do I not pay? Same as a bonus. Do you get paid a bonus? Do you not get paid a bonus? That is at the discretion of the employer. Right. So that is a typical if-then scenario. Now, you do not work, you do not get paid. Well, that is true. You do not work, you still get paid. We see it happening in our day-to-day. That is happening as well. But where it will be a problem and where you take each other to CCMA or to labor court is when I actually work and you then do not pay. That is going to be a difficult problem. A contract would have been broken. Yeah. So that is a typical example, and then I think you can relate to this example in this situation. So the only time an if statement is going to be false is if the first part is done, but the promise is not kept. The condition is met, but the condition is not kept. That is when we are going to have a problem. All right. Then let's look at if and only if. So if and only if is quite special. If and only if is quite special. I'll come to this just now. Because if and only if says, let me just take this out. It will say it is derived. Let's say it is derived from saying, so the symbol is this. It is derived from the, it is equivalent saying P implies Q and Q implies P. Right. So there are two conditionals that are conjuncted together. Remember, conjunction says this both need to be true. What this does, it says, if you work, you get paid. This is this part, right? P is you working. P refers to working. And then Q, let's say it refers to, Q refers to getting paid. Let's say this is the scenario. Right. So the first part will say if you work, you get paid. Right. The second part will say if you get paid, then you work. Right. So this now, there's a condition attached to you getting paid. So if you get paid, it means you are supposed to work. Right. I have paid you, now work, but then you are not working. So it takes away this aspect of the implication. So it is a conjunction that goes both ways, where each of the inputs are both conditions for the other. So that is the special case that we have for if and only if. So we say we see it with a double-headed arrow. To this one. Implication, we said it can be if then, if P then Q. It can also be read as Q if P, and it can also be read as P only if Q. So these you need to know. These you need to know. Right. Another application of implication is when they use the word unless. So if they say P unless Q, right? Here we are saying, we said P, let's assume P to say you work and Q to say getting paid. So you say you will work unless you get paid. Well, maybe may not bring what I want to bring into full light. Rather, let's go ahead and use those critical situations that is happening. You can buy cigarettes unless there is a lockdown. Unless there is a level 4 lockdown. I'm sure you have seen that this has been getting so much attention in the press. You can buy cigarettes unless there is a lockdown. What does this statement say? Right? So we are saying you are allowed to buy cigarettes unless there is a lockdown. So if there is a lockdown, you are not going to be able to buy cigarettes. If there is a level 4 lockdown, then you are not going to be able to buy cigarettes. So what is this saying? How can we interpret this to plain English? We are saying the lockdown is prohibiting you buying cigarettes. So if, say this is P, buying cigarettes, and Q is level 4 lockdown, if there is no level 4 lockdown, then you can go and buy cigarettes. If there is no level 4 lockdown, then you can buy cigarettes. Right. So this is the interpretation when you have P unless Q. So label your P, label your Q, then interpret it as not Q implies P. Right? That is the interpretation of unless. Right? You find also that we are also going to have other equalities which we are going to look at. P implies Q is equivalent to not P or Q. Right? Also, whenever we have a conjunction, the negation of a conjunction distributes the negation inside the brackets, right? This means not both P and Q. This is not both P and Q, and this then means not P or not Q. This is equivalent to that, not P or not Q. Right? Then same applies here, not P or Q. This one says both P and Q are false. Right? Only true when they are both false. So this is equivalent to not P and not Q. Because you see that P or Q is that, so the negation of P or Q is simply to say we want to find if this is true, the negation of true is false, 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 true. So it is only going to be true when both of them are false. That is that. In this one, it is going to be true. So the negation of that is going to be false, true, true, true. It is only going to be false when both of them are true. So not both P and Q, it can be one or none, but never both. So when none of them are true, it can be true. When one of them is true, it can be true, but when both are true, it is false. Then we're going to look at these two, but for now we're going to pack them. We're going to look at them more in detail when we look at conjunctive normal form and disjunctive normal form. But this is the distributivity laws of conjunction and disjunction. Right. Now, we are done with propositional logic. Let's look now at quantifier logic. Let's look at quantifier logic. Right. Quantifier logic starts with the introduction of what we call a predicate. Right. And we say a predicate is an expression of one or more variables defined over some specific domain. A predicate is an expression of one or more variables defined on a specific domain. Don't beat yourself too much about the definition. Right. Let's look at what a predicate is. So over here I said an unofficial definition says, right, predicates are atomic sentences but with variables instead of nouns or subjects. So a predicate is an atomic sentence where you are going to have the subject is a variable. Subject is unknown. Or you can say it is a variable. Right. So a predicate contains variables, and once variables are replaced with constants or nouns or subjects, then they become atomic sentences. Right. When we look at the arity of a predicate, it is the number of inputs of a predicate. We can say, for example, X is a boy, right, represented by boy X, right? So this is a predicate statement where X is representing a set, right, which is what we had here, defined on some specific domain. So X will be defined on some specific domain, and we are going to have boy as our predicate representing X is a boy. So we have our predicate statement. When we substitute X with John and say John is a boy, it becomes an atomic sentence. Right. So what we see here is that X will represent a domain of some sort. So maybe now domain X, there was John, there was Mary, there was What else? Let's say there was um, uh, let's put in another name there. Let's say September, and we close off. Now, if X represents this domain, it means we can now substitute and say, let's substitute John, let's substitute Mary, let's substitute Kuda, let's substitute September. For each of these substitutions, we are going to get a true or false value. That is what a predicate entails. Right. Now, for this module, you're going to find these constantly used predicates. You're going to find these constantly used predicates. Right. Oh, so what is the difference between a predicate statement and an atomic sentence? Right. So if we use this one, in a predicate, we use a variable. Right? We use a variable. And because there's a variable, predicates do not have true or false value. Predicates do not have true or false values. True or false values. Right. So if I say X is a boy, the first question I need to ask is, what is X or who is X? Right. So I cannot ascertain a true or false value based on a predicate. Right. Then if I were then to say X represents this set, right, which is the domain, and given from our definition, it says a predicate is an expression of one or more variables defined on some specific domain. So though we may not be given X, or the variable is going to be for some domain, right? But then as long as we have a variable, we cannot deduce the truth value of the predicate, because we do not know what X refers to, what subject X is. Right. So X can be a million things. So if it is can be a million things, we cannot come and say X is a boy is true. X is a boy is false. We first need to ask, what is X? Who is X? Define X first. Then you can substitute X with a subject, then we can assign a true or false value. So in here I said the difference between predicates and proposition or declarative sentences is that in declarative sentences you're going to have a subject, right? In predicate statements you're going to have variables representing subjects, right? Variables representing subjects. Right. So if you have come across a database, if you have come across databases, right, you realize that it is going to have, let's say it's a database for a bank, right? You are going to have sort of the name. You're going to have, say, age. You're going to have sex, maybe. You're going to have, say, race, right? And you're going to have, say, gross salary or monthly income. Let's say it's income, right? So we've got A and B. We've got A and B. So in this case, these are going to be variables. They stand in for specific elements. So whenever we see a name, it is going to be standing in for 100 or a million possible names, right? So we can use name as a variable. Right? It will be name. If I say name x, I would say x is a name, right? But the name itself, what I'm trying to put across here is the name is going to be a variable that can be used. So I can say a loan, or rather, let's say approved for loan. Approved for loan. Then we have got name. Right? So this predicate would say name has been approved for loan. So can you tell me whether this statement is true or false? Name has been approved for loan. Would you say this statement is true or false? Would you say the statement is true or false? Would you say this statement is true or false? Or can it be assigned a true or false value? Right. Now, you got the first part correct to say it does not have a subject, so it's false. So the first part that you got correct is it does not have a subject. Since it does not have a subject, it is neither true nor false. You cannot really assign a truth value. You are not able to assign a truth value because you do not know who has been approved for loan or the subject that has been approved for loan. Right. So that is the scenario. Now, I was going to say that these predicates are the ones that you're going to encounter a lot in the course of this module. Right. This table is not going to be given in the exam. You are expected to know what these predicates mean, right? And how many inputs it can take. So you see that the interpretations of this, so the first ones up until here, they take in one input. We call these unary predicates. They take one input in. We call them unary predicates. Right, now with these unary predicates, what's going to happen? What's going to happen with these unary predicates? You cannot have it taking anything more than one input and less than one input. It has to take exactly one input. So the subject is described as is. A is a tetrahedron, state A. Cube A is a cube. Dodec A is a dodecahedron. Small a is small. A is medium, A is large. Then we come across these ones that have two inputs. We say they take binary inputs. Bi meaning two. So this needs two arguments for it to work. Right, the same as sum or plus. So plus needs two arguments to work, one over here and one over there. If you say 1 plus in a calculator and then you say equals to, you're going to get an error because you have not given the plus operator two arguments. So when you are saying same size, same shape, you're comparing between two elements to say A and B have the same size, same shape. A is larger than B, A is smaller than B, A is in the same column as B, same row as B. Right? Adjoins B, left of, right of, front of, back of. Now, you need to know the definitions. Right? Same row and same column is easy, right? Left of, we are saying A is located nearer to the left of the edge or of the grid than B. Then, interesting, left of and right of becomes defined. Front of nearer to the front than B. Then adjoins, I saw adjoins somewhere. Adjoins is located on adjacent but not diagonal. So if I've got 4 cells, say I've got this, right? Adjacent means that. Right? This is what adjacent means, the colored ones, not diagonals. Then between A is between B and C. So it means A, B, C are in the same row or the same column or they're diagonal. And A is between B and C. So you have to be in the same row, and you have A should be between B and C, or same column, A rather A is between B and C, or it has to be a diagonal, and then you are going to have A between B and C like that. So that is the only time when between B and C applies. So if it is not a diagonal, then it is not possible, or a row or column. Right. Now, additional to that, I'm going to add on quantifiers. So a quantifier on a predicate, right, it is a symbol and it is used to express universal claim. So we said X defines what we said was a domain. So a quantifier acts on the domain. The quantifier acts on the domain. And the one that we have in front of us is called a universal quantifier. It says that, right, for all the elements, right, for every element under this domain, this holds. Right. So say we have got our set, I don't know if you remember it, so we had the predicate boy X, and then we said X referred to John, I don't remember the other names, Kate, Kuda, say Ashley. Right. So say this is our domain. If I come and I say this, what will be the new interpretation? Right. So we express in English using quantified phrases like, so this symbol is represented by everything, each thing, all things, anything. Right? So all elements, or rather simply all, we can see all over there. This is going to say all X are boys, or rather it will just say all boys. We have all boys in the set. Right? So given a domain, where X is this domain, and someone says all X are boys, or all elements are boys, all things in set X are boys, or all things under the domain are boys, all elements under this domain are boys, right? Now you can assign a true or a false value. I've got the domain. If you say every element in this set is a boy, I'm going to come and say that's false, because Kate and Kate and probably Ashley are not boys, right? So therefore, the statement to say given this domain and I say this, it does not hold. So this says all boys, every boy, each boy, any boy. Now, the other operator that we have under predicates is going to be an existential quantifier. So the universal quantifier, we found that it blankets or it applies across the whole domain. Whereas an existential quantifier says in the domain, there is at least one element that makes it true. Right? So if we still have boy X and we still have X referring to John, predicate. Right? It would say, if I put this quantifier, it will say there exists a boy in the domain, right? So you say some boy or something, at least one boy, a boy, n when it is relevant to use, right? So there exists some boy in this set. So if I come and look at my domain, I say, yes, Kuda and John, these are boys, so I just need one. Kuda is a boy, therefore this statement is true because there exists a boy in the domain. What? There exists a boy in the domain. Now, furthermore, this is subject to interpretation. This is subject to interpretation. So usually with universal quantifiers, right, whenever you use quantification, it is used with a variable, never a constant, only a variable. So say we are given boy x and home x as predicate. Right? So if someone comes and says, if you want to say all boys are home, and then if you want to say some boys are home. How would we write it? Right. Look, say we have got the set x is going to be equal to, again, Kuda, Mary, John, and Kate. Right. So if I want to say all boys are home and some boys are home, so some boys are home, I can come and say there is some x such that x is a boy and x is home. Do you agree? Do you agree with my reasoning? X is a boy and X is home. Right. Do you agree with my reasoning? There is some boy who is at home. Now, if I want to say all boys are home, one would be tempted to say all the other boys are home. Right. Now, the temptation will be very high to say this. But then this would be wrong. And this stems from the fact that both of these, or the conjunction specifically, is commutative. So commutative meaning something like this: a plus b is equals to b plus a. So we say addition is commutative. 1 plus 2 is equals to 3. 2 plus 1 is equals to 3. So these two are also equal. So by virtue of that, it means we can say everyone at home is a boy. Right? When we look at it from this perspective, it's going to say someone at home is a boy. Right? Which means the same thing. If there is some boy at home, it means someone at home is a boy. That works out fine. Because if there is a boy at home, then someone at home is a boy. That should work out fine. But if you are saying all boys are home, right, that is not going to be equivalent to saying all that are home are boys. Those are two different statements. So for universal quantification, this is what we do. Whenever we introduce a universal quantifier, so this is wrong, we say, who are we talking about? Who is the subject? The subject is boys, then if you are a boy, right, then let's describe the subject. They are home. So this is then the interpretation of all boys are home. We are saying all that are boys, all that we know to be boys are home. So in that case, we can say, let's apply this set to our three statements. If we start here, right, some boy is home. If Kuda or John are at home, then this statement will be true, right, because one of the boys will be home. It doesn't matter whether Kate or Mary are there. As long as one of these is present, then that will hold. If you look at the one that we marked wrong, if you look at the one that we marked wrong, if you look at this one, right, this says all that are home are boys. So if Kuda is at home and John is at home and Mary is at home, that statement becomes false. Right? But we want our statement to say all the boys are home. In our statement, Kuda and John are both at home, but also Mary is at home. The presence of Mary is making it wrong, whereas our statement was only focused on boys. So now we come and say X. What does X refer to? It refers to boys. It says all boys are home. Right. If you are not a boy, nothing has been said about you not being a boy. So you can be at home, you can be not be at home, it doesn't really matter. We are only worried about the boys being at. So if there are no questions, I would like to stop here. So I want you to review this, understand it maybe before Thursday, so that when we start on Thursday, we are starting on question 2 and we're applying directly what we've learned today onto. Right, so enjoy the rest of your night. I will be seeing you on Thursday and we'll be doing questions only on Thursday. Good night and good